Good morning to all, one and all. Myself, Dr. Rajendra Tiwari, and presently I am associated with the Department of Electronics and Communication Engineering at BBD University, Lucknow campus. I am here to present a paper in 10th International Electronic Conference on Sensor and Applications. And the topic of my article is IoT based fuzzy logic controller for smart soil health monitoring, a case study of semi-arid region of India. We have got Mr. Rajan Prasad, a senior faculty in the Department of Computer Science and Engineering, and Mr. Adesh Kumar Srivastava, another senior faculty member and School of Management at BBD University, Lucknow. So here is the outline through which I am going to discuss during this presentation of mine. We will start with the introduction of the topic, literature survey. Then one of the most important topic that we have got is the research gap, on which we need to focus. And research gap, as we have seen that this is the basically area where we find the differences and actual problem statement we are getting in this at this point. Then we have got objective and specific aim, proposed methodology. We will go with the result analysis, and then conclusive future scope of the work. So basically, we start with the topic as per the topic Internet of Things. We look out that IoT basically represents an enormous collection of the interconnected devices that collect, store, and utilize data. So basically, we have seen that IoT, Internet of Things, are simply a medium. You can say we can say that through which we people are going to transfer the data, primarily that we are getting from the different sensors for the most important parameter for an application. We people are going to whenever we require to share the data over the net, we make use of IoT, and these are the gadgets that are linked to everyday items such as cell phones. So we have got enormous applications where we are making use of IoT, and it is really said like that it's referred to as an ecosystem of the network machine. So we can say that it becomes very important nowadays, a prominent you can say tool and technique for network machines, where we are going to execute different tasks. We have different applications. This ecosystem has the potential to detect soil health and enhance crop yield. So basically, in our this topic, where we are going to discuss, we will look at the potential capability of the soil to provide the yield, output yield. Whatever crop we are going to grow in that field, it depends upon the quality, its health, the you can say the output yield, how much we are going to get the output. Sensors are often used to detect soil properties. We have got enormous ample sensors that are going to study, that are going to provide the data about the health of the soil. So in this problem that we have taken, we are primarily focusing on the agriculture domain, and we talk about the health of the semi-arid region, the soil that we people are going to make use to grow the crop in semi-arid region, where we do have got the climatic conditions in such manner that which may affect the crop. These sensors are controlled by software applications, and the primary application of sensors and monitoring are security and warning. So by our system that we have proposed, the system will provide information, provide message, provide alert, provide alarms to the farmers about the health of the soil, that as per the time span, with the span of time, how they are going to maintain the health of the soil, it will be provided. This information is primarily provided by our proposed system. In order to get this problem enunciation of this work that we have put on, we have gone through certain base papers as a literature review. They are on your screen. We have gone through Andrews et al., Masto et al., Velasquez et al., Bastida et al., Sparling et al., and Sanga et al. So these are the papers. 5 to 6 paper we have taken as the base paper to our problem. From where we have started the actual work of our proposed work. We have seen ample work has been done by these researchers with their optimum result output, and then we start with the work. And the basic thing that we have seen here, that the above base papers, the authors, the above work done by the authors, they have not used real-time health monitoring. They precisely work on the simulated data, or they have taken the data from where and then simulate it and then get the properties of those soil. But in our work, in this proposed work, we have straightway gone to the real-time health monitoring, and the data that we have taken, it is real-time data. So this is the thing that semi-arid region of India covers more than 12% of the whole land coverage. We have seen that semi-arid region. So there is a large area, there is a large scope for this proposed system where we can implement and test and then use for the betterment of the farmers. By analyzing the soil nutrients, we can improve the productivity of the soil. Utilization of these lands for agriculture help to food safety to citizen. By using IoT and fuzzy logic controller, we can analyze the precise data and extract the useful information. So normally we have seen that it works as a smart system, a whole smart system which is going to work on its own property, its own learning day by day. The system will become more and more smarter as we are going to train them by using this fuzzy logic controller algorithms. Then we have got objective and specific aims. So basically in our work we have fixed three to start with. We have three objectives, that is collection of real-time data by deploying the multiple sensors in the study area, design and deploying the fuzzy logic controller for analyzing the collection data from the sensors, developing cloud-based application for sending the alert messages to the farmers based on fuzzy system decision. So here we have seen that basic three part. This is we can say that basically we have got three different modules in our system to collect the data from the sensor, that is real-time world. We are going to design. We have designed logics by using FLCs, and then so as to analyze the collected data and extract the useful information from there. And then third one is developing a cloud-based application through which we can send the messages to the farmers, to the end users. This is the simple schematic block diagram of the proposed methodology, proposed systems, which has got sensing module, and that is NPK sensors, signal converter, data converter basically A to D, fuzzy inference system FLCs in order to develop the logics, IoT product modules used for sending the alert message. The block diagram says like this: semi-arid agriculture field. So we have got the test field. From those test field, the real-time data is extracted. We are getting the real-time data through the NPK sensors. Then we have got data converters which are converting the physical parameter into electrical one. Then we have got the basic important thing, that is the logic controller. We have implemented FLCs, fuzzy logic controller. With the help of fuzzy logic controller, we have developed certain algorithms, certain rules which are going to test the precise of the collected data, so that they can provide the desired output, desired information to the farmers. And then last one is processing unit, where we are making use of Arduino processors in order to process the data, in order to extract the decision from the collected data. This is an overview about the study area that we have taken. It is basically we have randomly chosen Mahoba district of the Uttar Pradesh, which has got the exact properties, exact climatic condition that can provide us the real-time data in semi-arid area. The soil over there, we have studied the nature of the soil through the sensors, taken the data and then used in our system. So the table 1 shows the most important parameters in our study, in our this proposed methodology, proposed model. That is simulation, time of simulation that we have used is about 300 seconds. Area covered 1500 meter into 1500 meter. We have chosen a random area in the semi-region where we fix the sensors at different points so as to extract the information. Frequency of the channel is taken as 2.4 gigahertz. The path loss is a free space, so we are having very less path losses over there. Propagation limit that we have got is -111 decibels per meter, and transmission power is also 15 dB per meter. So these are the parameters which plays a very important role in order to extract the information, in order to process the information, and then fed back to the farmers the alert messages that, for example, by the span of time they need to put nutrients, they put fertilizers, they need to add on certain chemicals or fertilizers, natural fertilizers, in order to get organic production in that region. So this is an overview about fuzzy inference system, a little information or basic information about the use of fuzzy logic controller, how we are going to make use of fuzzy logic controllers, how we are going to develop the algorithm for that one. So basically the system is like this. We have got input sensor data, we have got first step is fuzzification of the data. So fuzzification is simply we see that we could have more than 2 logics in between 0 and 1. More than n number of logics we could have in fuzzification process. We are converting the input data which we are getting from the sensors through fuzzification. Inference system is basically we are going to decode, we are going to extract the information, process it, take exact decision for that one, and defuzzification and the knowledge base. The important knowledge is we are get through this system. So basically here what this FIS will provide us, we get data from the sensor, we provide the nutrients value of the soil, health of the soil in terms of different parameters that could be shared later on with the farmers so that they can act at the promptly act at the right time in order to just improve the properties, qualities of the soil that may enhance the productivity of the crop. So this is a basic relation that tells us about the fuzzy phenomena, how we are going to make this one. It's a very basic mathematical that we have taken for our area that we have taken. Based on that, we took this parameter, mathematical formula, and that is nothing but a Gaussian membership function. So we make use of these two things, triangular MF and Gaussian member function. These two mathematical relation we have took in order to make the fuzzification of the system, in order to develop the algorithm of the fuzzy logic system. These are the outputs that we get after implementing the FLC concept, after getting just inputting the data to the FIS system. The output that we get for different membership function for nitrogen, phosphorus, potassium is shown here. That is the membership function. Similarly, the table, another table 2 represents the logic for fuzzy inference rules that we have implemented in our proposed system. If n is low, p is low, k is low, then health is low. So basically, we have taken these three main things: nitrogen, phosphorus, potassium, in order to extract the information, health information of the soil in the semi-arid region. Different item. Now when we talk of cloud, when we come to the cloud, where we need to share the data with the use of IoT, we are getting certain protocols there, and it's a very basic thing, that constrained application protocol. In this proposed model, we have make use of COAP model, which is very interactive, very easy to understand by the clients and users, and through which the different messages, different alert messages could be shared with the farmers. So this block diagram basically represents the basic concept of the COAP, and it is basically application, request response, message, and UDP, and end user of this system. And this is this screen simply shows the output where we are going to just get the message. We are going to send the message through it, and it could be a message like that. Okay, now by the time that time has been passed out, now the soil needs fertilizer. So with the alert of this message, the farmer may act, and then they will put the fertilizer in the soil. So similarly, likewise, we could have different alerts from time to time to the fertilizers to the farmers so that they can take action at the right time, and the production of the crop, the production of the crop can be enhanced. So this is here we have made the comparisons, the work that we have mentioned in our literature survey. So the result that we get after just executing our proposed model, it has been compared with the different works that has been taken by different researchers, and the result is on in the PPT displaying for you kind information. So now let me conclude my presentation with this slide, that the work that has been put forward here, proposed here, it is challenging to routinely evaluate soil environment nutrients in agricultural fields due to conventional testing methods. So this system basically have a edge over the traditional techniques they are normally followed by the farmers. They are making use of the knowledge of their own, or maybe suggested by some co-farmers that they have got, that okay, now we can just provide the water to the soil. After that, they are taking randomly, the farmers are taking the decision randomly. So sometimes it may happen that the soil may not need the nutrients, but still the farmer is putting the fertilizers in the soil. So that is the basic comparison with the traditional one and the approach through our proposed model. The farmers may save their time, may save their money also, may improve the yield of the crop also with the use of this one. The suggested system notifies the farmer by SMS of the absence of the critical soil nutrients from time to time. It does this by using system integrated NPK sensor, as we have already discussed, and fuzzy system. The experiment shows that suggested system is accurate, low cost and intelligent. IoT system that instantly alerts the farmer by SMS about the fertilizer that needs to be applied at the right moment. Truly, because if the farmer act at the right time, at the dire need of the soil, only then the things can be improved, only then the crop production can be enhanced, and the farmer may get benefited from that one. And this system might be utilized as a helpful tool for farmers in the agriculture industry. So it has been proposed primarily for the agriculture industries, for agriculture purpose areas, and primarily at the semi-arid region where the climatic conditions are different, where the soil health monitoring is very important, where the nutrients of the soil may not kept long because of the nature, environmental condition over there. So with this system, with the use of this system, the farmers may get benefited, certainly without any doubt. These are the few references that has been shown here for your kind information, which we have referred in our proposed work while executing our task, while executing our simulation work.